So if you really think about the architectural plans for a massive modern skyscraper, you sort of expect them to be overwhelmingly complex, right?
Oh, absolutely. You're picturing like endless rolls of schematic paper.
Exactly. Or just enormous digital files taking up, I mean, gigabytes of server space somewhere.
Right, filled with structural diagrams, load-bearing calculations, material tolerances, all of that.
Yeah, but nature's blueprints, they operate on this completely different scale of efficiency, and it's practically invisible to us.
It really is.
I mean, you hold a tiny, dried up melon seed in the palm of your hand, and, well, you are actually holding a highly compressed zip file, essentially.
That is a great way to put it. A biological zip file.
Right. It's an entire architectural schematic for a sprawling, complex organism, and it's fully encoded, ready to deploy. I mean, it is a master plan disguised as literal garbage.
It's the ultimate disguise, really.
Eh.
Primarily because we interact with these biological marvels every single day without even a second thought.
We just toss them in the compost bin.
Exactly. Or the trash. But under the precise necessary conditions, that tiny speck of biological debris unspools its genetic code.
It's crazy to think about.
It contains exact, rigorous instructions for seeking out structural support, manufacturing lateral branches, and eventually synthesizing soil and sunlight into something sweet and nourishing.
Just sitting there.
Yeah, just sitting there, entirely dormant, waiting for the exact right environmental catalyst to trigger that grand deployment.
And that profound transformation from overlooked kitchen waste to a sprawling, living architecture is the exact mechanism we are unpacking today. Welcome to the Deep Dive.
It's great to be here.
Today is July 25, 2026, and for everyone listening, we are examining a single, highly specific dispatch from a blogger named Ang. The post is titled, Notes on Gardening, Part 966, Growing Honey-melon, or, to use its formal botanical designation, Cucumis melo.
The title alone establishes such a fantastic context. I mean, Part 966 immediately grounds you in this ongoing, almost epic longitudinal study of tending to an environment.
Yeah, it's definitely not a weekend project.
No, not at all. This isn't a fleeting hobby. It is a sustained practice.
So at first glance, for you listening, this might seem like we are just dissecting a simple gardening diary entry today.
Right.
But our mission today is to look at the mechanisms underneath the dirt, so to speak. Because this brief dispatch actually operates as a masterclass in behavioral psychology, structural engineering, and community building.
It really packs a punch for such a short post.
It does. We are going to extract the broader operational lessons that Ang has embedded inside the very physical mechanics of cultivating a honey melon.
And, the human psychology packed into just the opening sentences is remarkably dense.
Oh, totally.
Ang initiates this entire narrative by confronting an incredibly universal, often uncomfortable human experience, which is the friction of procrastination.
The friction is almost palpable in the text. Ang writes that harvesting honey melon seeds and propagating them is something they have, quote, always wanted to explore.
Yes, always wanted.
But due to unforeseen reasons all these moons, the plan was continually postponed. I just find that phrasing, all these moons, so evocative. But honestly, it also feels like a trap.
A trap in what way?
Well, I feel like declaring you have always wanted to do something is actually a curse. You elevate the task to such a mythical status in your mind that you inadvertently paralyze yourself.
You are touching on a very well-documented phenomenon in behavioral psychology there. It's closely related to the Zeigarnik effect.
Okay, remind me what that is again.
It dictates that we remember uncompleted or interrupted tasks far better than completed ones. So when a task sits in that someday category, particularly one we claim we have always wanted to do, it accumulates cognitive weight.
Oh, wow. So it just gets heavier the longer you put it off.
Exactly. It becomes a monumental life goal rather than just a simple action. And the friction to initiate a monumental goal is enormous. You start waiting for the idealized conditions.
Right, like the soil needs to be perfectly prepped.
Yeah, the seasonal timing must be flawless. Your schedule needs to be clear. And since those perfect conditions rarely align, the, unforeseen reasons for delay just keep compounding over all those moons.
It reminds me of like buying a pristine, incredibly expensive leather-bound sketchbook.
Oh, I know exactly what you mean.
Right, you want to draw, but the book is so beautiful that you become terrified of ruining the first page with a mediocre sketch. So the book just gathers dust on your shelf.
The pressure of perfection completely prevents the practice.
Yes, but Ang breaks this paralysis, and the catalyst isn't like a sudden burst of profound motivation. The catalyst is just leftover seeds from a fruit they were eating anyway.
Just kitchen scraps.
Literally. Aang simply notes, we might as well grow them. Does that sudden shift happen entirely because the materials are viewed as disposable?
The shift happens because of a sudden dramatic collapse in the stakes.
A collapse in stakes, okay.
Yeah, think about it. When you go online and purchase a rare packet of heirloom seeds, you pay for premium shipping, you carve out a designated grid in your garden bed, your sunk cost is very high.
You're fully invested.
Right, the expectation of success is immense. But when you are standing at your kitchen counter, holding the slimy leftover seeds of a melon you literally just consumed, the economic and emotional investment is zero.
The baseline expectation for trash is zero.
Precisely. The baseline is zero. By deciding to plant the leftovers, Aang completely removes the burden of the idealized project.
The perfection filter is completely bypassed.
Yes. The internal narrative shifts from, I am embarking on a grand, flawless botanical exploration, to, we have this biological refuse on hand, let's just run a low-stakes experiment and see what happens.
That is such a huge mental shift.
It is. And for anyone listening who is currently stuck on a massive project, this is a highly effective strategy to bypass your own cognitive friction. Find a way to downgrade your materials to leftovers.
Stop waiting for the expensive, perfect setup.
Exactly. Seize the opportunity when raw materials organically present themselves, effectively tricking your brain into lowering the stakes of entry.
So, by lowering the stakes, Aang finally shatters the inertia of all those passing moons. The leftover seeds are going into the dirt.
Right.
But this immediately introduces a new set of challenges because Aang now has to confront the physical, biological reality of the organism they are trying to cultivate. We sort of transition here from behavioral psychology into botanical mechanics.
And Aang demonstrates exceptional observational foresight here. They aren't just blindly placing seeds in the soil and hoping for the best.
No, they have a whole structural analysis going on.
Right, they're preemptively analyzing the structural tendencies of the organism.
And those structural tendencies are exactly what I want to challenge, actually, because on paper they sound disastrous.
How so?
Well, Aang describes the honey-melon as a vining plant, highlighting two very specific characteristics. First, it grows, quote, long, weak main vines. Second, it produces multiple side branches known as laterals. Now, if we apply basic engineering principles to this biological design, it seems completely contradictory to me.
You're looking at the weak core.
Yeah. The main vine is the core foundation of this entire living structure. If your core is inherently weak, but it is somehow expected to push out and sustain multiple sprawling lateral side branches, doesn't that doom the entire architecture to collapse under its own weight?
It's a fair question.
I mean, in any human construction, a weak core means catastrophic failure. How is this a viable biological strategy?
Well, it is completely logical to view a weak core as a liability. We are culturally and architecturally conditioned to believe that stability requires massive, unyielding rigidity.
Right, we want steel beams and concrete pillars.
Exactly. We look at oak trees with their massive solid trunks and we equate that density with success. But in the specialized world of vining plants, a weak main vine is not a structural flaw.
It's not
No, it is a highly evolved strategic adaptation.
an adaptation. I am really struggling to see how inherent structural weakness provides any sort of competitive advantage.
To understand the advantage, you really have to look at energy economics. Building a solid, rigid trunk, synthesizing all that heavy lignin and cellulose just to fight gravity that requires a massive, continuous expenditure of the plant's metabolic energy.
Okay, so a tree spends most of its energy just trying to stand up straight.
Precisely. The vining plant essentially bypasses that entire infrastructure cost. By maintaining a weak, highly flexible main vine, the plant radically alters how it interacts with its environment.
It just refuses to play the oak tree's game.
Right, it refuses to waste its limited energy resources trying to stand alone. Instead, its anatomical weakness forces it to actively seek out external support. It delegates its structural integrity to the environment around it.
Oh, wow. That feels incredibly analogous to the shift in the tech industry from monolithic on-premise servers to cloud computing.
Oh, I like that comparison. Tell me more.
Well, you stopped spending all your capital building and maintaining this massive, rigid central server room, which is like the oak trunk, right?
Right.
And instead, you outsource that heavy lifting to a decentralized network. You rely on the surrounding environment to support you.
That is an outstanding parallel.
Yeah.
And what happens when a tech company no longer has to spend all its capital maintaining that central server room.
They can redirect all that saved capital into rapid expansion. They can spin up new features, test new markets, and just scale horizontally almost overnight.
Which is exactly what the Cucumis melo does.
It scales horizontally.
It really does. Because the honey-melon saves all that metabolic energy on its core, it can rapidly explode outward, pushing all those multiple lateral side branches into new territory to maximize photosynthesis and fruit production.
That is brilliant.
The profound takeaway here is that recognizing and accepting an inherent weakness is often the prerequisite for rapid scaling.
That is a great way to phrase it.
Eng doesn't judge the plant for its weak main vine, nor do they try to force it to act like an oak tree. True mastery involves looking at the raw material, understanding its inherent nature, and realizing that if you want this specific organism to thrive, you don't demand it be stronger.
You just provide the exact right scaffolding for it to lean on.
Exactly.
But, that reliance on the environment places a massive burden on the scaffolding itself, which brings us directly to Eng's next hurdle, which is the architecture of support.
The trellis dilemma.
Yes. Eng doesn't merely recognize the need for a structure, they get surgically specific about what geometric shape that structure must take.
It's the intersection of biology and bespoke infrastructure. Eng notes in the dispatch that they actually possess an underutilized pot with a trellis readily available for this project.
Which is so tempting.
It introduces a classic logistical temptation, yeah. The desire to use the tools you already have on hand simply because they are accessible, rather than because they're actually correct for the job.
It is the ultimate manifestation of the I have a hammer, so everything must be a nail fallacy.
Exactly.
But Eng pauses. They look at the biological reality of those multiple side branches known as laterals, and they recognize a fundamental geometric mismatch.
Right, because Eng writes that a round vertical trellis may not be suitable for such a plant, as an A-frame trellis is more appropriate.
Let's unpack the spatial geometry of a round vertical trellis for a second. It is essentially a cylinder, right?
Correct. And by its very design, a cylinder dictates a specific type of growth. It forces everything upward and inward, confining the organism into a tight, highly restricted vertical column.
If I were to map that onto an organizational structure, a round vertical trellis is the equivalent of a rigid, top-down waterfall project management system.
Okay, I see where you're going with this.
Imagine you have this brilliant, sprawling, agile team. They thrive on lateral thinking, branching out into cross-functional ideas, and exploring secondary solutions.
Those are the laterals.
Right. And then you force them to work inside a heavily siloed, top-down corporate hierarchy. You are taking an entity designed for horizontal spread and shoving it into a vertical tube.
And the laterals have nowhere to go.
Nowhere. They will end up tangled, competing for the same limited sunlight, and ultimately suffocating each other.
The suffocation of the laterals is the inevitable result of unmatched infrastructure. And Eng visualizes this constraint perfectly.
They see the trap.
They do.
Yeah.
They realize that if the honey-melon is going to execute its biological mandate and throw out lateral branches, it requires a structure that accommodates horizontal expansion.
Which is where the A-frame comes in.
Exactly. An A-frame trellis operates on an entirely different geometric premise. It may start narrow at the apex, but it offers a continuously widening, sprawling base.
It gets wider as it goes down.
Right. It is a broad, stable canvas that actively encourages and supports the horizontal spread of the laterals while still providing the necessary vertical anchor for that weak main vine.
It is just an incredible display of operational discipline. Eng refuses to succumb to the sunk cost fallacy of the underutilized pot sitting in their yard.
Which is hard to do.
It is. They are literally matching the physical architecture to the biological reality of the project, rather than stubbornly forcing the project to conform to convenient inventory.
We see this mismatch constantly in business and personal development, don't we?
All the time. We implement generic, out-of-the-box systems and then act totally bewildered when our highly specific, nuanced goals fail to thrive within them.
Adapting the environment to serve the organism, rather than forcing the organism to survive the environment, that is the hallmark of a true expert. Eng understands that the infrastructure must be bespoke to the subject's operational reality.
Oh, absolutely. Eng has conquered the cognitive friction of procrastination by utilizing low-stakes leftovers. They have analyzed the biological mechanics of the weak vines and the energy-efficient laterals, and they have cognitively mapped out the necessary geometric shift for from a restrictive cylinder to a bespoke A-frame architecture.
They have a flawless plan.
Right. So you would logically expect the very next sentence of this dispatch to be an action item like, so I sourced the lumber and constructed the A-frame.
But it isn't.
No, the text takes a sharp, highly pragmatic pivot that practically halts the momentum.
It is a pivot that really separates a theoretical visionary from an experienced practitioner. After outlining this flawless architectural strategy, Ang writes, "Nevertheless, we shall see whether the seeds sprout in the first place before we proceed with the trellis arrangement."
That sentence acts as a complete reality check. And let me propose a slightly cynical hypothesis here, considering they postponed this project for all these moons. Doesn't this abrupt halt feel a bit like setting up for failure?
How do you mean?
Well, they have the seeds in the dirt, they know exactly what structure is required, but they refuse to actually build it. Is this a subconscious defense mechanism? Like, are they just expecting the seeds to rot so they don't have to build the trellis?
It is really easy to interpret a pause as pessimism, especially with that history of procrastination. But in this specific context, it is supreme pragmatism.
Pragmatism, not pessimism.
Right. It is elite-level resource management. Ang is demonstrating the ability to hold two entirely separate states of mind simultaneously.
Okay, what are the two states?
On one hand, they possess profound vision. They know the mature botanical mechanics. They have engineered the perfect A-frame solution.
The grand plan.
Yes. But on the other hand, they refuse to confuse their theoretical model with empirical reality. As the saying goes in science, a seed is a hypothesis. Germination is the data.
Oh, I really like that framing. A seed is a hypothesis, germination is the data. You don't scale the infrastructure until the data proves the hypothesis is viable.
Exactly. Why expend the caloric, financial, and temporal energy constructing a complex A-frame structure for a biological promise that hasn't even materialized yet?
Because if it fails, you're devastated.
Right. If you build the massive architecture and the seeds fail to sprout, you haven't just lost a few leftover seeds. You have suffered a major deficit of time and labor.
Which feels terrible.
And that deficit leads directly to burnout, which drastically reduces the likelihood that you will ever attempt the project again. By enforcing a waiting period, waiting for that first definitive green shoot to break the surface of the soil, and conserves their operational energy.
They allow empirical reality to dictate the expenditure of effort.
Exactly.
It is a highly disciplined restraint. But the scope of Ang's resource management doesn't actually end with their own energy conservation. The very final sentence of this dispatch expands the perimeter of the project entirely.
It certainly does.
Ang writes, depending on how many seeds sprout, the extras will be given to my neighbors.
And with that single sentence, we transition from a closed, isolated system into a communal ecosystem.
It is a fascinating trajectory when you zoom out. Think about the origin point of this whole thing. This entire endeavor started as an isolated, postponed dream, sparked by a pile of literal garbage sitting on a private kitchen counter.
Yes.
And the projected endpoint is the intentional generation of community connection.
It perfectly illustrates the concept of biological and creative surplus.
Biological surplus, right.
When a system is properly aligned, when the stakes are managed, the inherent nature of the organism is understood, and the empirical reality is respected, that the system rarely produces just enough to survive. It generates excess.
It scales past the individual.
Right. It produces more ideas than a single team can execute, more momentum than a single person can harness, or, in Ang's case, physically more sprouts than a single A-frame trellis can accommodate.
And the instinct for so many of us would be to hoard that surplus,
Yeah.
right? Or perhaps ruthlessly cull the extra sprouts and throw them back in the compost because they don't fit our exact plan.
But Ang recognizes the excess, not as waste, but as a mechanism for connection.
Exactly. The leftovers that bypass their initial procrastination are now going to physically branch out across property lines and take root in the surrounding neighborhood.
It's beautiful. The project stops being a solitary diary entry about an underutilized pod and becomes a shared environmental reality.
It underscores a crucial reality about productivity and creation, I think. They are rarely solitary endeavors in their maturity.
The fruits of focused labor, or even just the initial excess byproducts of that labor, they naturally seek a wider integration. The margins of Ang's private experiment become the catalyst for someone else's garden.
The density of insight in this brief blog post is just truly remarkable.
It is a phenomenal text.
Let's trace the arc of what we've uncovered today for everyone listening. We observed how the heavy, paralyzing weight of a postponed dream was finally dismantled by the zero-stakes freedom of utilizing leftover garbage.
Right, bypassing the Zeigarnik effect.
Then we broke down the evolutionary genius of a weak main vine, reframing structural fragility as a brilliant strategy for delegating the energy costs of stability to the surrounding environment.
Yeah, the cloud computing model of the garden. We examined the geometry of constraint versus the geometry of expansion.
The trellis dilemma.
Exactly. Learning the necessity of matching our infrastructure, the bespoke A-frame, to the actual sprawling lateral reality of our projects, rather than forcing them into the restrictive cylinders of our convenient inventory.
And finally, we explored the elite pragmatism of waiting for empirical data, the actual sprout, before committing resources to the infrastructure, which ultimately culminated in the beautiful translation of surplus into community sharing.
It is a masterful blueprint for operating in the world. And as we conclude today, I want to pivot slightly and leave the listener with a concept that underscores this entire dispatch, something we might call the stewardship of the mundane.
The stewardship of the mundane. I love the sound of that. How does that apply here?
Well, we spend so much of our lives hyper-focused on our primary intentional actions, right? The grand goals, the massive projects, the things we have always wanted to explore.
The big stuff.
Right. But Aang's entire journey, this cascading sequence of biology, architecture, and community, was not born from a grand finalized plan. It was sparked by a micro-decision in a margin of time.
The half-second pause before throwing the seeds away.
Exactly. The fruit Aang ate was the end of one plant's life cycle. By simply choosing to pause and retain the seeds, Aang became a vector for its continuity.
Wow.
It raises a fascinating question about our own daily environments. For you listening, think about it. What if the most profound, sprawling impacts we have in our communities aren't born from our heavily funded, perfectly orchestrated initiatives?
What if they're born from the scraps?
Exactly. What if instead our greatest impacts stem from the secondary, discarded byproducts of our daily lives? The rush drafts, the leftover materials, the casual conversations, the things that we simply pause long enough to recognize as seeds rather than trash.
That is an incredibly powerful lens to look through. We are surrounded by potential energy masquerading as refuse. It just requires the discipline to pause, lower the stakes, and recognize the blueprint hidden inside.
Well said.
Thank you so much for joining us as we unpacked the hidden architecture of this everyday dispatch. Keep looking for the potential in your leftovers. Make sure you are building the right structural support for your ideas, and we will catch you next time on The Deep Dive.